Welcome, fellow Toastmasters, honored guests, Madam Toastmaster. I was first introduced to her in elementary school. I was fascinated with her. Maybe it was that funny hat she wore, the way she had this circular kind of reasoning, the way she never repeated herself. I thought she was interesting and mysterious. But it wasn't all rainbows and roses. She could be difficult, like Carol, sometimes irrational and never knows when to stop. She is pie. Tonight we're going to talk about who she is, why she is, and how she is. Hopefully you'll learn to love and know her as much as I do. First of all, who is pi? Pi is the ratio of the circumference of a circle to the diameter. The circumference is a little more than 3 times the diameter. It doesn't matter if we're talking about my ring or if we're talking about planets that go around the sun, the ratio is the same. It's pi. And it's an exact constant. The interesting thing is, although it's an exact constant, we can't represent it exactly. We cannot write a fraction to represent pi exactly. We can't write a decimal to represent pi exactly. If you were to write it as a decimal, it would just be a long sequence of non-repeating numbers that go on for infinity. That's who pi is. We know who she is. Why is she so important? It's all about rhythms. Rhythms are cyclical. Cycles are circles, and circles involve pi. Rhythms, cycles, circles, pi. That's all you need to remember. Reminds me of that 1980s pop song, La Macarena. Heartbeat breathing, the way we give birth. Satellites, the moon, circling around the earth. The math behind it is older than dirt. Hey, Macarena. I was never a good dancer. Pi is everywhere in rhythms. The planets, Kepler's law of periods, as the planets orbit the sun, includes pi. Body temperature, circadian rhythms, has pi in the calculation. Waves, whether it's waves in the oceans, seismic waves of an earthquake, radio waves, light waves, gravity waves, they all involve pi. Even economic cycles. There's a guy named Martin Armstrong that posits that an economics confidence model that business cycles are pi 1,000-day intervals, approximately 8.6 years. Even the Macarena probably has pi in it somewhere. We know who pi is. We know why she is so important. But how is she calculated? This is where it really gets interesting. Everybody knows Archimedes. Archimedes was a mathematician that lived around the turn of the first millennium. Archimedes had a way of calculating pi. He would take a circle and then he would inscribe a polygon. Polygon, in this case, a square. He would circumscribe another polygon, another square. Squares are pretty easy to figure out the perimeter. It's just 4 times the side. Circles, not so much at the time. He would take the perimeter of the inside square and the perimeter of the outside square and then average the two, and that would be a rough approximation to pi. As the number of sides of the polygon increased, the precision of pi increases. the precision of his approximation. So you go to a pentagon, a hexagon, an octagon, 10-sided, 100-sided, 1,000-sided, you get a pretty close approximation of pi. Archimedes was well ahead of his time. Now, 1,400 to 1,500 years later, mathematicians came up with something called a series, an alternating infinite series. Looks something like this. Pi over 4 is 1 minus a third plus a fifth minus a seventh plus a ninth. It's really the same concept. This alternating is almost like going inside the circle, outside the circle, inside the circle. It's very similar to that polygon approach. And as it continues towards infinity, this fraction gets smaller and smaller. It's like adding more sides to the polygon. So these mathematicians, independently in fact, Leibniz, Gregory, no relation, and Nilakampha, all came up with this formula to calculate pi. The beauty of this formula, unlike the polygon, today we can use computers. You can use your desktop computer or your laptop, plug in this formula, and calculate pi to 8, 10, 16 digits. That's really all we need is 16 digits for interplanetary space travel and astrophysics. 16 digits is enough. But computers have calculated pi to over 1 trillion digits and counting. So you're saying, why would you calculate it to that precision? It has no practical use, but it's the mystery of it. We don't know what's the next number in the sequence, the next digit in the decimal. We don't know. It's the mystery of it that's so exciting. In fact, think about this in conclusion. If you were to write out pi to 1 trillion digits or to infinity, every number sequence mankind has ever known would be in there. Carol's credit card number would be in there. Bing's lottery picks would be in there. Jen's social security number, as an HR person, we have to expose your social security number. It's in there. Everybody's numbers are in there. It's kind of mind-boggling. So I hope tonight you know who pi is, why she's important, and how to calculate it. And hopefully you will love her and know her as much as I do. Thank you. I'm Toastmaster.